Welcome guys, this is our 4-bit breadboard computer, and right now I am loading the code into the program RAM, that is the RAM we have to store the program. Program is very simple. Load A, load B, out and jump back to the load B location. Here's the blue color deep switches for address locations and red color deep switches for loading the data into the RAM. Address location 0 stored load A instruction. At the location 1 we stored 0. Location 2 we stored 1, and location 3 we stored 1 again. 1 on the location 2 is the load B instruction, and 1 on the location 3 is the data. Location 4 we have stored out instruction, that is 2. On the location 5 we have stored jump instruction, that is 3. On the location 6 we have stored 2, that is the address location of load B instruction. This program output is increment of the number from 0 to 15, and this will happen into the loop. Here in this computer, micro instructions are tied together. It means counter out and memory address register in are tied together. It means one only signal is required for both these instructions, and in entire programming this counter out and memory address register in we required maximum 8 times. Yellow and white color wires have no good contacts with the breadboard, and so that is very frustrating for me. So whenever you are going to build such project or any such circuit, take consideration of the hookup wires. The good quality hookup wires will give you the better result. Push and lock switch I have used for programming and running mode, switching from programming to running and running to programming, and one blue color LED attached to show we are into the programming mode. This computer starts its programming with the fetch cycle. Fetch cycle is of two steps. First step is 00. At these steps, counter out and memory address register in will takes place. Second step is 01. At this step, RAM out, instruction register in and counter enable will take place. Third and fourth steps are for instruction execution. For instruction load A, we use the second step, that is we fetch the data from the RAM by using counter out and memory address register in. Need not to get confused, because this counter out and memory address register in signals for fetching the data, not the instruction. Final step is step number 4 for execution of instruction. For load A, data from the RAM location is directly fed into the A register using the micro instruction RAM out A in. Load B is the same as load A. For the out instruction, fetch cycle is the same. First we fetch the out instruction, and then we will take the ALU out and put that ALU out into the output register by using those particular micro instructions out ALU and in output register. On the screen you can see the increment of the output by 1. Next instruction is jump instruction, that is the 3. In this programming we have put the location number 2 for the jumping back to the location, that is the location of load B instruction. So whenever we come to the location 6, we will jump back to the location 2, and this process will happen continuously in loop. You can see on the screen as I am giving the clock pulse, the programming running accordingly. You can see the memory address register is a program counter now. ALU is working properly. Every execution of instruction required 4 clock cycles. This program takes the 7 location of RAM memory. At the location 0, load A instruction is there. At the location 2, load B instruction is there. Location 4 is out and location 5 is the jump instruction. Let's closely observe how 4 is incremented to 5. See the steps and instruction. So there is no change into the output till we will get the out instruction into the instruction register, and the step is 3. You can see that out instruction 2 into the instruction register. Now see how the RAM data fed into the B register and A register. So there is no A register feeding because we only fed into the B register again and again. Step number 3 of out instruction will update the output register. This updated value fed back into the A register. You can see that. You can also see the ALU also updated to 7. 6 plus 1 is 7, but this value is not updated to the output register yet. This job is done by the out instruction. See, you can see that it will update it to 7 on the step 3 of the out instruction. Let's move our important topic, that is control unit. Okay, let's see our control logic part. So in our control logic we have 74SC, 76, 74SC, 4514 and 6 7 OR gates IC, not 6. Actually there is a one more IC we have used over here, and for what those ICs are used we will see it. This 74SC 4514 has 4 address lines. So first least significant bits we have connected to 74SC76, and upper 2 bit we have used for instructions. So bit number 0 and 1 we have used for steps, and bit number 2 and 3 we have used for instruction. Okay, let's see what is happening. When there is a 0, 1, 2 and 3 are coming on the address line, we will get the output Q0, Q1, Q2, Q3. Here we have to do some trick to get the output when there is an instruction on the MSB part, that is the address line 2 and 3. We have to match that output with the steps. So whatever the instruction is at that time, we don't care about that instruction, what is that instruction. So we will only execute what our steps wanted to do with the control logic. For example, when there is instruction 1 and step 1, so we will get the output Q5. At this point, we have concern about the step only. So when the step 1 is there, we will get the output Q1. And when the whole address line have the phi on that address line and we are getting the Q phi, then we will make it that we will make those two outputs, that is the Q1 and Q phi, common output, and make these two outputs, that is the Q phi and Q1, as two inputs, and we'll get the one output. And we're doing the same thing, so we will get the only required output. For this purpose, we required 8 input OR gate. During the fetch cycle, program counter fed into the memory address register. This required single clock pulse. and this will happen maximum 8 times during the program. Same thing is about micro instruction, RAM out, instruction register in, and counter enable. Counter out and memory address register in will use the first step 00, and our second step is RAM out, instruction register in, and counter enable, that is the 01. Output signal for counter out and memory address register in has 8 input signal. I will show you the demonstration of that thing on paper. Also, we will see the circuitry which shows us the 8 input OR gate giving the output to this counter out and memory address register in, and so on. It is enough for this today's video. We will see whatever remaining into the next video, and I will try to explain you how our control logic is working in detail. Thanks for watching.